1. Hook cold starts can ruin your app's first impression. They cause delays that frustrate users and can cost you money. 2. The real problem: cold starts occur when a serverless function or a containerized application has to spin up from a dormant state. Here's the kicker: users expect an app to respond instantly. Research shows that if your app takes longer than 3 seconds to load, about 40% of users will abandon it. In the world of cloud computing, this can mean lost revenue. If your app has 1,000 users daily and each user's average order value is $50, a mere 1-second delay could lead to a revenue loss of up to $18,000 a year. That's serious money for startups. 3. The simple explanation: let's break it down. In serverless computing, when a function is called for the first time, or after a period of inactivity, it needs to be initialized. This process includes loading the runtime, dependencies, and your code. That's where the delay comes in. Think of it like starting your car on a cold morning. It takes a moment to warm up before it runs smoothly. The same principle applies to your serverless function. Cold starts are particularly problematic for functions that experience sporadic traffic. They may sit idle for minutes or even hours, only to be called upon suddenly, leading to that frustrating delay. 4. Real-world example: let's look at a startup called FoodieApp. They launched a meal delivery service using AWS Lambda for their backend functions. Initially, they were thrilled with the idea of a pay-as-you-go model, but they soon faced significant challenges. One Friday evening, they rolled out a marketing campaign. Suddenly, their user base surged from 100 to 1,000 users per hour. Unfortunately, their Lambda functions weren't optimized. The cold starts averaged 6 seconds during peak times. As a result, users started abandoning their orders. The startup saw a 25% drop in conversions that night alone. With an average order value of $30, that meant a loss of $7,500 in just one evening. After that, they had to rethink their approach to cold starts. 5. What to do instead. Step 1. Analyze your traffic patterns. Review your application's traffic data. Identify peak times and periods of inactivity. Aim to understand the frequency of function calls. If they're sporadic, cold starts are likely. Step 2. Optimize function configuration. Choose the right memory size for your functions. Higher memory can lead to faster cold start times. Aim for at least 512 megabytes for a balance between cost and performance. Step 3. Keep functions warm. Implement a warming strategy. Schedule a cron job to invoke your functions every 5 to 10 minutes during low traffic periods. This can reduce the number of cold starts significantly. Step 4. Preload dependencies. Minimize the size of your deployment package. Only include necessary libraries and files. Use a tool like AWS Lambda layers for shared dependencies across multiple functions. Step 5. Use provision concurrency. For critical functions, consider using provision concurrency. This keeps a specified number of instances warm. It can cost you an extra $0.015 per hour per function, but it's worth it for critical applications. 6. Common mistakes. Mistake 1. Ignoring traffic patterns. Many startups fail to analyze their traffic data. Regularly review your CloudWatch metrics to understand when cold starts happen. Mistake 2. Not preloading dependencies. Large packages lead to longer cold starts. Use AWS Lambda layers to manage dependencies efficiently. Mistake 3. Underestimating memory allocation. Using too little memory can slow down your functions. Experiment with different memory settings. Start at 512 megabytes and adjust based on performance. Mistake 4. Lack of a warming strategy. Forgetting to warm functions leads to inconsistent performance. Implement a scheduled warming process. Run a simple script to trigger your functions periodically. Mistake 5. Overlooking provision concurrency. This option can prevent cold starts for crucial functions. Use provision concurrency only for high-traffic functions to manage costs effectively. 7. Quick checklist. Analyze traffic patterns using metrics. Optimize function configurations based on performance data. Implement a warming strategy for low traffic periods. Preload only essential dependencies. Consider provision concurrency for critical functions. 8. Summary plus CTA cold starts can drastically affect your application's performance and user satisfaction. By understanding the problem and implementing strategic solutions, you can enhance your app's responsiveness. Analyze, optimize, and apply best practices. Avoid common mistakes, and you'll see improvements in user retention and revenue. If you found this video helpful, please comment below with your thoughts and subscribe for more actionable insights on cloud engineering. Your feedback helps us create content that matters to you. Bonus practical tip: if you're unsure what to pick, start with the simplest option that ships today. Then measure for 7 days, latency, errors, deploy time, and cost.